Okay, suppose right now in our neural network project assignment, we would like to add some graphics display to illustrate the structure of the neural network for the user. So in that case, we needed to write graphics, logic to display the neural network. So before we add that function to the neural network, let us learn a little bit about the graphics issue in Windows Phone application first. So if you look at the control, right? The control play let me see, play as the interfacing object to interact with the user. So the most important feature should be the face text, right? So even though that is a text, but actually the text is drawn by the computer. It's not just will appear there. So everything, including the back color, everything all control is actually drawn by the CPU, by the computer. So everything will be drawn via some draw function or some graphics object there. So we need to know that in the run. So everything can be every controller can have a custom drawing on it. Does not matter whether it is purely a line or a character. They are all drawn by that graphics object. Okay, so suppose right now we have button there, right? So if you want to draw something on some control, you need to get so-called graphics objects or that control. So once you grab these graphics objects, you can use that object to draw graphics content, including character, on that graphics device. So that is the concept of graphics on WinPhone control. So finally, eventually we would like to display our neural network on this panel, right? So panel again is a user interface control. So we can do that. So suppose right now if I add you can practice that with me. Okay, so suppose we add a button, try to draw something. Try to draw something on this panel too. That will do. Okay, so if I double click on button 4, so make sure you know the variable name of this panel too. Split container 2 dot panel 2, right? So this is my name. Yours probably should have your own variable name there. So mine is the split container 2 dot panel 2. Okay, so if I subscribe the quick event here. So as I say, if you want to draw graphics on some user control, you need to get a graphics object from that control too. So the control should be split container 2, right? This is my variable panel 2. So right now I get a control variable. Then you try to find a function. The function create graphics. So you will get the graphics object of the panel 2. So that is the idea. So you don't need to supply any argument there. But instead, once you call this function, you will get a graphics object. So you need to prepare a local variable to get it. So that is graphics. It's a new data type in Dynamic Framework. So what is exactly a graphics? What is it? Well, it is regarded as a virtual device which can show interfaces content. So definitely Windows, right? The screen is a device. Now we can show something on the screen, right? So similarly, graphics might represent a printer, laser printer too. So because we like to display our contents on the laser printer, the document printed out, right? So graphics is actually an abstract device, but currently our graphics right now we get it is from what? From the panel 2, right? So the graphics G is actually referring to the panel 2. So what panel 2 shown is actually drawn by this graphics object G. So once we grab the G, we can do everything. So knowing that, we know panel 2 is a container uses control, right? So it always has its coordinate, screen coordinate. So the origin of that coordinate system is in the left top corner. So remember that panel 2 is a screen device. So right now the coordinate is measured in pixels, right? And the original is in the left top corner there. So during the graphics, we usually should ask help from certain kind of graphics object or structure. So usually we will involve this rectangle, right? Rectangle is a structure, not a class. The structure of C# dynamic framework. So we call it IC. You don't need to new it, but sometimes if you see new, it's not allocated. It is not allocated in the heap. Struct is a struct. Struct in C# is actually a value type, data type. So there is no any memory instantiation. I mean, for this rectangle. But rectangle is really helpful for us to regularize our display, our graphics item. So later on you will see it. And not just the rectangle, we also have point. Again, that is a structure related to the drawing. So from time to time, we will we will use rectangle and point there. So you might specify P1, P2. Well, again, that is a similar. That is a structure too. So once you access this property, okay, we have X. So right now the coordinate is internal what? Internal G. G is a graphics device. So right now G is actually this panel 2. So original of this coordinate system is in the left top corner there. So every coordinate is measured in pixels. So P1, suppose P1 X equal 10, P1 Y equal 10. We need to use semicolon, okay? That is, okay. Yeah, because right now P1 is not initialized, so well, similarly, you can write in this way, new point 10, 10, there. I'd like to emphasize that again. It is not related to memory allocation because the point is a struct, not a class. So actually, P1 is located within the stack memory, and the take two integer memory space there. So P1 is there, and how about the P2? So if we instantiate P2, maybe 150. So as I say, the x-axis is pointed to the right, and y-axis is pointed to downward. So actually, it's a left-handed coordinate system. So we have, and also, so we can specify the rectangle. Rectangle have 3 constructors there, so we might use this constructor xy. That means the top left corner of that rectangle with respect to its parent. So if I say that it's 10, 10, width maybe 80, height 60. So these units are in pixels. So we have rectangle, we have P1, P2. So P1, P2, since they are local variables, so it can be changing. All right, so usually we'll use G, for example, fill, ellipse. So if I try to paint an ellipse, fill with a color. So what kind of data you need? Okay, we need a brush. So brush is related to the graphics, right? So another. Well, I think this should be class BIUSH. Yeah, it's a class. It's a class. So if you do not have an object or brush, you can use this class. It's a utility class. Brushes. Dot. There are several predefined brush there. The property name simply show you the color name. So if I go, the word go, brushes, so I like to use the gold color to paint this ellipse. And how about the size of this ellipse? Okay, as you can see, the explanation right here. Oh, okay, I can specify rectangle. So rectangle have a location, specified by its left top corner, right? And then width. So if I like to draw an ellipse within this rectangle, I simply send this rectangle as the second argument there. All right, so I have G fill ellipse. Simple, right? Okay, so let's try it. All right, there's ellipse shown up there. So probably you can see, well, 10 pixel, right? So this rectangle is right here. To the left, because right now these coordinates are described in terms or defined in terms of the coordinate system or the graphs device. So graphs device, the relationship in this point. Okay, fine. So this is the field. How about draw? G also have a draw ellipse function can be invoked. So what kind of argument should best? So therefore, oh, okay, we need a pen. You don't have a pen object, right? So how about pens? Yes, we have this class. Also, there are a lot of stock or predefined pen there, so you can simply invoke its property. So probably I will call it red. Use the red color, and similarly, especially the same rectangle there. So I have fill ellipse, draw ellipse, and probably let me try G. Draw rectangle, another function, draw rectangle. If it is draw, definitely you need to specify pen. So I have pens again. This time I blue, this blue color, similar rectangle there. Okay, so let us see what happens. Fill, draw. So we draw twice, right? One is an ellipse, another is a rectangle. Okay, that is what you have. So if we gold color, fill ellipse with a gold color, and then we draw ellipse, that means just boundaries on the ellipse. And finally, we draw a rectangle there. All right, so simple and straightforward. How about the pen, the point? G, draw line. Okay, right? So we still need a pen, x1, x2, so draw line, hence narrow. Okay, it's a dark red color. See, P1, P2, special point, P1, P2. And what kind of function we can draw? String. We can draw string. So actually, all the character or letter, actually they are drawn on the device. So draw string. What kind of string you like to draw? Okay, NTUIE. All right, so you need to special fun. We don't have a fun object, right? But remember that this function is within this main form. Main form is a graphics user interface. Main form, we do have a font ready there. So if you click on this main form, right, we have a default font associated with this user interface. We have a font already there. The name probably just font. So if you don't like to create a new font, you can use this start font. And then, as I say, the text or character actually they are drawn. It's not printed there. So see, we still need to specify a field color, right? So this time, yes, process again we use the stock process. So this time I might call it green. Fine, green. And then you need to specify a point. The point F is a flow versions of point. So that means the x coordinate, y coordinate are in float format, not in integer format. So it's okay because there are still another kind of invocation there. Rectangle, special rectangle, flow x, flow y. So probably we should just use this one. So if it's 10, it's okay because the integer can be converted implicitly into float number. But you cannot use this one, 10.0. 10.0 is actually a double type. Double type cannot be implicitly converted into a float type because double type is double precision. Float is a single precision. But if it is integer, it's okay. It can be automatically implicitly converted into a float. So they should know that. So we print the NDUI there. So this time we add a line, right? We add a line. Yeah, draw there. Okay, great. So draw it. So that is what we have. NTUIE there, right? And we draw it right points 10, 10 there, and then 80, 60, right? Okay, that is the whole idea about drawing. All right? So this is drawing. But if you look into this situation, if I it's gone, right? What happened? If I click it again, the graph is shown up again. But if I move Windows, the size, this panel size has been changed. So in fact, panel is an user interface object. User interface object needed to show its face, show its outlook by calling certain kind of function. Because right now we specify well, so your backcolor is a light yellow color, right? So once this control refresh or invalidate, this control needed to paint its face. But for this panel, it does not recognize there is an ellipse there, right? So ellipse is simply added by this button click. So the graph content drawn there will be gone once this panel is refreshed or repainted by the CPU, by the computer. It is not there. So it is not the way we show the graphics there. Okay, so never mind. Up to this point, we know all the graphs content should be drawn by a G object, graphics object. So right now we call it a G. So why not just let us maybe wrap it up as a function. Void draw graphics, and then take an argument graphics G. So we kind of wrap up all these lines as an independent function here. It's okay, right? So in that case, I don't need to create an object from the panel 2. So right now, this function turned out to be a free function. So once you supply me a graphics object G, I will draw these contents on that graphics object. So it will be much more flexible for now. Okay, so if you have a G, you can call this one. So okay, it's again similar. In my button 4 click event, I can call this function draw graphics. I need a G, right? So how can I get a G? Okay, it's simple. Split container 1, split container 2, that panel 2, create graphics. Just call this function. So this function will return the graphics object of panel 2 back to me. So I pass that to this function. So I will see the graphics drawn on my panel 2. So what else I can do? Okay, remember that this is button 4, right? It's button 4. And how about this guy, this property grid 1? Property grid 1, button 4, they are also users control, user interface control, right? So if I call this function many times, but this time it's not panel 2, button 4. Well, that would do, right? So every control has its own graphics object. Property grid 1. Create graphics. All right, so everything create graphics. How about phone itself? Well, probably you will not see it because right now we have a split container obscure the phone, so it's useless at all. How about this list box? LSB layers, right? LSB layers. All right, so kind of change that. We wrap up all these graphs function within function. So we give it a G, so we have that function. All right, so if I click on bottom 4, you see what kind of graphs has been drawn. Okay, please notice that once I move my cursor out of this bottom 4, it's gone, right? Why? Because there's an event happen for the bottom. Right now, your cursor has left this bottom 4. So bottom 4 user and this user interface control will repent itself. And during the repent, there's no any information about this graphic object there. So computer do that. Computer refresh the outlook of bottom 4 for the bottom 4. And when bottom 4 repent itself, there's no any information about this ellipse rectangular stuff there, right? So it's reasonable. All right, so how about this guy? Similar, right? This is the list box, so let me click on it. No one preserved, right? So the reason is that, as I say, every control is subject to repent event once the size is changed or obscured by another application, and then once it wants to replace Windows operations will call its repent event function, and there is no information about the graphs there. All right, so I think we have 4, right? Panel 2, bottom 4, public grid. Okay, public grid, there's nothing showed up, right? So the problem is a little bit different in there, so we do not see it, right? Okay, fine, never mind. So in order to keep these graphics, live on certain kind of control, for example, if we want to display the neural network graphics always on the panel 2, right? So in that case, you need to subscribe pen event to do customer painting there. So if I click on this panel 2, and then I subscribe its pen event, there, subscribe, I double click it. So this pen function will be repeatedly called by the operation system, by the Windows, in case this panel 2 needed to refresh and repent itself. So within this function, I can call what? I can call this function. If you want to draw these contents on the panel 2, you need to do it in this way. So draw graphics, call this function, supplied with the graphics object of this panel 2. But since this is a pen event, right? This pen event is an event handling function. So that can be, this function can be called, can be subscribed, can be invoked with different pen event. Those, right now, we know only panel 2 subscribes this pen event, right? So definitely the object is panel 2. But never mind, this function is still can be shared by different kind of user interface control. So we don't need to bind the graphics object of panel 2 to this function. Instead, we will use this parameter pass in from this event handling function, pen event. So if you look into the parameter pen event argument E, once you click on it, you will see there is a graphics object there. And also, we have a quick rectangle there. Quick rectangle, just for example, if this center is the panel 2, so quick rectangle will be this size. So that should be 0.0, and then the width and height, we have this extra information for you. All right, so we subscribe the pen event of panel 2, create this function. This is basically a pen function. So we can directly use e.graphics But not just e-graphics, we also need to give that function, because sometimes I have a large screen, right? And sometimes the screen has been shrink or enlarged. So in that case, we prefer that our graphics, our neural network graphics will be scaled automatically, right? So in that case, not just pass in the graphics object, we need to tell the graphics function saying that, well, how large or the panda event or the panda canvas for the function. So we also need to support in this guy, e dot creep rectangle there. So we will change a little bit about this function. So graphics there. So we will take another rectangle. It's a rectangle. I call it bound. So right now we have this bound, right? So in that case, probably your width, right? So for example, this rectangle, the width, it depends on the bound. So I might say, well, my width is bounds. Divided times, make it half, okay? How about the size? How about the height? It's not fixed. It depends on the bounds. Height divided by 2. Bounds width divided by 2. So I'm saying that if your graphics elements were automatically enlarge or shrink, you need to set the size depending on this bounding rectangle there. Okay. All right. So let me go back here. So what kind of rectangle shows, right? Since it's a panel tool, right? So in that case, space container two, panel 2. There is a code. I don't see client rectangle there. Client rectangle. So every control has a client rectangle there. So similarly, since it's a bottom 4, right? So bottom 4, and then in this case, bottom 4. Client rectangle. And we know probably we're not sure the graphics content, so it's okay. So we leave there. And LSP layer client rectangle. So we can upgrade our draw function, not just the graphics object, also the boundary and the size of the canvas that I can draw and control there. So in that case, this rectangle will be depend on the size. Either way, it's large or smaller in that case. So it's our case we like to have. Interesting. Let me see. Height rectangle bounds with. Oh, okay. Divided by 23. That's why. Just half of it. All right. This is what you have. You see, we have subscribed this free container 2 panel to subscribe this pen event. So it always appear there. And if it's size, you see if I change size. Did you see that? I'm using the width is just 1/2 of the width of that bound. But not the point, right? Point is not scaling down, but the rectangle has been scaled with respect to the current boundary, current client rectangle. So this is the case we like to have. And if I draw, click on this button 4, so this function will show there, right? So again, if I move my cursor out of this button, it is gone because I did not subscribe the pen event and draw the content of this for this button 4. So similarly, if we change size, scroll it, it's gone, right? So I'm saying that you need to subscribe pen event, do some customer painting there. In that case, the graphs can be always associated with your user's control. Okay, that's the idea. All right, so and then probably sometimes we prefer the string, for example, NTU, we prefer that it print down just in the center of this rectangle. That will be much easier for us to specify the location, right? So in that case, drawString, we need to invoke another drawString function. So we will need another class to help. It's called string align, string alignment. I'm going to call it string alignment. Excuse me, string. Okay, let me check it. G draw string. This font brush black. String format, point F, string format over rectangle. This one is we prefer. Rectangle flow. So we have a rectangle. It's okay. Rectangle is in integer. Coordinate is integer, and flow is in flow. So by default, a rectangle, well, probably not, but you can cast that. So we need to specify another string format and specify a rectangle to run the string there. So we need string format. string format, string format. SF, we need to do extension object. So we have string format object, and we specify its property alignment with respect to the bounding area. So it's an enumeration, near, far, center. So we prefer put it in the center. SF line alignment. There's a line alignment. String alignment center 2. So we have a string format object to help us to regularize the location of the string with respect to a bounding box, bounding rectangle there. So in that case, we will specify this one, and then we will specify ECT there, SF. So this string is drawn on this point, right? So this point is 10 point there. But this time the Taiwan should be drawn with respect to this rectangle, And since right now the string format is that specified that horizontal wise is aligned in the center, vertical wise is aligned in the center. So that should be this string should be drawn within the center of this rectangle. So this is Taiwan, the location of this one, the location of this string. So as you can see, it's always drawn in the center of this rectangle. All right, but as you can see, font size is not scaling down, right? So you need to do that by yourself. If you prefer the font will be shrink when the size of the canvas is reduced, so you need to do that by yourself. And probably sometimes you have a thick line width. You will make that scalable down too. So in that case, you need to specify the size. But right now, since the pen, the width of the pen is always 1 pixel, so it does not matter at all. Okay, so these are the function we prefer to use. You see, ellipse. So right now our chart can be scaling down, scaling up easy, but not the point, right? The location of the point. I did not specify the location depending on the current boundary, bound. Okay, is there any question about the current progress? So what we have done is that, okay, we have a draw graphs function specified. Basically, you need to specify the graphics object. and also give me the size of that canvas, so I can use this information to scale the graph's contents to be displayed on this graphics. But in this case, the font, because I did not shrink it, right? So font. So probably you need to prepare your own font. How can we special our own font? So we have a special font, my font, new. So there's certain way to construct it. Font family. Family string size. You see, size is in float. So in this case, I might specify area. Area is a font name. How about the size? And my coded size should be depend on bounds height divided by, it's large, right? Divided by 10. I don't know. You need to specify gradually. And since it's flow, so I can specify that divided by 10f, 10.0f. So I have personal font. So in this case, I might not use the font or the font. I use my font, especially. And how about the pen? Right, so we have a pen. We have draw rectangle, blue pen, right? Pen's blue. So you can also have it's your customer pen. For my pen, new pens. You need to specify color. So another data structure is called struct color. COLOR is another graphics related struct. Colors. No, color dot red or whatever. Okay, blue, right? How about width? Okay, width depends also on bounds height divided by maybe not 10, maybe 20. I don't know. We can try it. So now I have my pen, which scale with respect to the current size, right? So in that case, I'm not going to this rectangle. I will use my pen to draw it. Well, probably not this one. The point, draw line, marrow. Okay, maybe I change it to marrow, and then use my pen to draw this line. Right, so you see what is the difference? Right now the font size is large, right? And this line is also the width is depend on current bound. If I enlarge it, you see that right now font size is pretty large, right? And how about the line width? Line width also increased. So you need to do that by yourself. And so just keep that in mind. The size of the canvas is important for us to arrange our graphs element there. Okay, so we have this function. So how can we associate this function with our neural network? So let us go back to our neural network here. So this is our propagation multi-layer persuasion, right? So we simply provide a function, similar function, name form, draw graphics, right? So we might call it what? So hidden neuron right here. Hidden neuron make a lot of words. All right. So here we will provide a public function. Void draw MLP graphics. It's not recognized, right? G rectangle. It's not recognized. Bound. So we prepare a function here. So let the visitor help us graphics is located within this namespace, system.drawing. Rectangle C2. Alright, so we have this function ready. So you need to focus on what kind of graphics element will be drawn. If a user provide a graphics device and then tell you the size of that canvas, you need to draw it there, right? So basically, it will depend on what? Depend on once your neural network is constructed, right? After config, right? We know the size, and it's after that, only after that, you can do that. So we need to bypass this algorithm. So new, once we know the end, and that means once this function is called, then we can draw. Otherwise, we cannot draw ourselves, right? So we can check about the end. Whether the end is ready or not, right? So end. So if n equal none, return. We're not going to draw anything because the structure or the multi-layer position is not specified yet. So once we this function is called, user provide in the neural number, then we have n specified, right? So n contain all the structure information about our neural network. Okay, so right now you need to print the graphics displayed for your neural network. So if we quickly go through with a print here, excuse me. So what in our mind is that so suppose right now n number of n excuse me, n is an array, right? So if n right now input is 9, suppose input 9, and we just have one hidden layer, neural number is 4, and the final neural number is 2, right? So if we have this situation, special, but actually in this case it was split into a 10, 5, and 3 because we always have a virtual node there, right? So if we know the 3, right, so we will divide well just 1 layer, 2 layer, 3 layer. So we can expect that. So probably we will set up this kind of initial offset, and then each part will be the size, right? So probably just 1/2, 1/2. So you need to print that in advance to locate the x coordinate or the first layer x coordinate right here, right? Okay, so depend on the number and then offset prepare 1, 0, 1, 2. So we call them, well, we'll call it W. Okay, so that should be 2 half of W, half of W. And then if we look into N0, that means the number of neuron, right? Number of neurons. So similarly, we'll divide by that, but we need to set Y offset. So if the this is H, so 2, 1/2 of H. So each neuron location, each neuron, the distance should be H. All right. So that is the rough idea of pointing the location of our neuron there. So draw M P. So we need to well check int W first. W equal what? Equal n length. Bounds W width, right? Divided by n length. So we have W already there, right? We have int x offset. That should be W divided by 2. That is the idea, okay. And then we need to look through for int, that should be the layer, start from 0, layer smaller than n that length, right? L plus plus. You might call it colon, okay. Well, layer, never mind. Stick on the layer. So, draw something, right? So we will have, well, we can set point, fine, point, P1, 0, 0. So point P2. And also we will have rectangle. My code box. 0, 0. How about we maybe arbitrarily set it? Fine. 10. So eventually we need to specify the box width, right? And height. So never mind about that. So we will locate the point first. Okay, so within this one, so n layer divided by the n l, the number of neurons right there, right? Number of neurons. So in that case, that should be inth for that. And then we have int y offset h divided by 2. So right now the x offset, y offset have been ready. So in this case, int x equal xof plus width times l. Right? So we start for int row smaller than n l. Plus plus y. So int value y equal y offset plus r times h. It's rough, okay, because right now all our coordinates are in integer, not flow or not real number. So probably at the end of each row or column, there should be a little bit of this differences there. So it's okay. So now we have xy. So since we have xy, and we may arbitrarily set the box size. Okay, so that depends stimulus. So depend on bound. So supposedly bound height. Never mind. We just have int box width. Now we depend on our bounds height, because usually it's in landscape size, so divided by maybe at most maybe 10, maybe 10. So if the window is really small, if box smaller, and we should probably maintain a minimum width. So if it's more than 10, then our box width remain into 10, not just shrink into a point. So box width is point. So we have box specified. So normally, this box width will depend on the size of your canvas, your bounds, so it's okay. But at least we should have 10 pixels, not just this speed, right? So, okay, so we have xy ready then. We will set rectangle, HT, not rectangle, box. We set x value into x minus box width divided by 2. I'll probably box width. So once we have special box width, okay, so we can half of divided by 2. So in that case, we simply offset box width. So around the box width is actually half of the box width. Box y equal y minus box width. We need to move it back because the idea is that means, oops. The whole idea is that this is our bonds, right? So right now we locate the point right here. So first point, second point, third, fourth. We allocate this point first. So each time we look through our structure, so we locate it. This is called x, y. But right now we need to put our box there. So x, y should get an offset, especially the rectangle x, y here, another rectangle y here. So we are not going to change the width and height of the box again. So we need to keep changing the rectangle x and rectangle y here in order to draw ellipse there. Okay, so we have x, y there. So we allocate the location of this box. After that, we draw it. How can we draw it? G there, right? So G, maybe fill, ellipse. Similar, right? How about the color? Up to you. Right now, simply use brushes. White. How about rectangle box? And probably you might prefer draw ellipse. Pens. Black. Fine. Box. And probably you would like to draw value, right? So x value, right? X. Draw string. So as I say, you might prefer specify what? String format. SA, SF, new, SF, align, center. SF, align, center too. So in this case, I can draw string x value, right? X value. Current layer, neuron R, right? I don't know. Probably it will screw up. I don't know. X value. Do I have? It's not X value. Yes, X flow. X. Layer. R. I don't know what's wrong. Something wrong there. Font. If I do not have any font, am I okay? We still need a font, right? So, font. Suppose I call it area. Size wise, probably 10 point. So my font. Maroon. Not point, right? So what we like to invoke is just this rectangle box. Draw the value there, and also SF. Okay, I have a local variable called x right here, somewhere here. So let me change it a little bit because right now it is confusing with the data member. So let me not access horizontal. Okay, never mind. XX. But here is x, our x value. Try to write the neuron value on the neuron there. Okay, so I prepare this function for whatever I would like to draw the shape of this neuron. So user need to provide me a graph is there. So okay, so since you have this function, right? So let us go back to the main form. So right now we still need to subscribe this one, but not this function, right? Not this function. But instead, this is form. This is main form. So what is the object name? My MLP, right? My MLP. So if since right now graphics function has been embedded in the MLP object, right? So if my MLP still not is instantiated yet, you cannot draw it, right? So we simply return. Otherwise we invoke its graphics function, draw MLP, right? So what kind of graphics you should provide? Well, definitely not sure. Because we like to show the neural network on panel 2, so I just give it subscribe this event first, and then I paste that graphs in. And also we need to get the client crypt rectangle for it. Okay, so let's see what will happen. So we have MLP ready. Why? I think that will crash. Nothing will draw it, right? Yeah, it's okay. It's still okay because my MLP has been instantiated somewhere. Let me check. Yes, we have instantiated initially, but it's okay. It is okay because within this draw function, even though we want to draw, right? Draw MLP. You see right here, if n equals 0, so we kind of move it up, save some resources. So let me set a breakpoint here. So when form is created, actually this function is invoked, right? Because we need to draw the panel 2. So this function is draw, and then within this function we call, since my MLP is not none, so we need to invoke this function. But came to this function, since n is none, it's not instantiated yet because user need to specify the architecture of that neural network. So it's okay. It's running, but it's okay. So supposedly user specify this 3, 4, and then reset neural network. So that means architecture has been changed. But this function will be invoked, right? N will be ready. W. Hidden neuron. Shape 4. Initial weight 7. Shown there. Sharp indexes. Okay, I forget about these parts. Let me just quickly assess. So back to your user interface. Once we reset the new, that means the user has changed this architecture. So user will click on reset, and once reset is clicked, actually we should update the contents of the neural or the structure of the neural network, right? So within this button at the end, we will say that okay, split container 2, panel 2. You need to refresh. So either way, you call refresh or call invalidate. They will ask the Windows to to invoke the pen event function for you. So panel 2 refresh. So we terminate this breakpoint, and then so come here, 3, 4, reset and end. Bottom one query, right? So it's about the time we refresh the content of panel 2. Okay, something wrong, right? But actually something has thrown in there. Okay, so if we enlarge the screen, change the size of the panel, skip larger, enlarge. Okay, so let us debug a little bit about what's going on there. So back to your function here, set weight, draw. MLP here. So it seems that Y value is not doing well. Box Y. Oh, okay, got it. Box Y always fixed right here, right? So box Y should be the Y offset. What? Time H. It's okay, right? Y offset determine, right? To half. The problem might come out from H. Okay, this one H should be equal what? Should be, oh, okay, I made a mistake here. Should be the bounds height divided by the number of neurons in this layer, right? So evenly distributed size. Okay, it's working, but it's a little bit weird, right? So 3, 4, 5. But actually, we will have a virtual neuron there, right? So in order to build up this correctly, and the input is not right. So, but again, that is dependent on your n value, your array of n value. So if I enlarge the panel size, as you can see, it is working, right? But probably, okay. As I say, the font size is fixed, so you need to, if you like to enlarge the font size and shrink it, you need to do that by yourself. But right now it's okay because right now we have 4 layers, right? Because you use especially 2 hidden neuron layer. But number-wise, you should prepare another hidden neuron here. So actually 3, 4, I think the problem came out from configuration, right? From this configuration. Let me quickly check about the content. So N0 input neuron +1. It seems okay. So once we know what kind of n value is, wow, it's weird. I did not do the input right. Okay, sorry about this. So input is wrong. And how about the n? 3, 4 is still not correct. 3, 4 is not correct because that is user special. We need to add it up. All right. So in here I need to change it a little bit. So within, yeah, n%. So I add another one here. I need to add another one here. So what you really need to do is that you need to open a file first. So So I provide you with 3 data sets. So either way, I choose breast cancer. So once we're ready, and then you specify the architecture of the hidden layer and click on reset. So you will see the structure correctly displayed right here. Okay, that is the way. But as you can see in the demo application, I kind of changed the size. The first neuron as just a point, right? So to make sure that is default. So it's easier. I mean, you come back to the draw MRP here, and then you check that if the error equal 1. If okay, so we needed to box with the screw fix. If R equal 0, you do it differently. Else. So we have a point there. So probably, can I draw a point? Yes, I can, right? So we have x, y, we have x, x, y ready. So actually I can just draw line, draw point. There's no need to draw point, draw line. Maybe not. Maybe fill, rectangle, and then brushes red there. Okay, so I need another, probably not. I'm not going to invoke this rectangle, just no way. Makes you need to do that. Okay, so then I just rectangle dot. And size probably should be fixed. Maybe I use 5 pixel for it. So I have 5 pixel. So I dot. So if it is 0, then rectangle and then dot. But I need to specify the dot xy. Dot x equal xs minus just 2 pixel. Dot y equal y minus. Just draw the hidden neuron differently from others. So I already in the file breast cancer. Oh, does not work. Why? If R equal 0, oh, I have error right here. I need to debug it. Okay, move it out. Why I need to move it out? Y determine first. And so I have a Y specified. Read the input file. Reset. Okay, now it's working. Alright, so this is what we want, right? What I have shown now in demo app. So right now 2, 4, 6, 8, 9 input. Output is just 2-dimensional, and then hidden layer is determined by the user. So user spread. So if the user change it, can I change it? No, I'm not able to do that. So never mind. Just once the user change the this list by reducing probably 1 layer and then change the number, so user click on reset again. So the structure will be displayed. Okay, I think that will be all for the graphics. So graphics, well, you need to spend a little bit about the time to get familiar with this function. So actually, if you type G dot and look into the available function, you can see there are a lot of functions there. Graphics, and you can also measure the size of the displayed area about for a string. Draw line, and also we have draw icon, draw cross curve, draw Bezier curve, draw arc. A lot of draw functions have been already there. And also probably can draw multiple lines, multiple paths, and also have a special path, and also draw polygon. So you can just export it more or less for that. And finally, what kind of draw function can be used? What a draw function can be used? As I say, right now it's simple. Right now we want to draw the neural network on panel. So panel is a screen, right? It's a graphics device too. But how about print it out? Well, we have suppose you provide a button here. And I call it print. So this button I will special as display style, image with text. So how can you print if we have a graphics or the MLP here? We can print it easily. So how can we print it? So you need to recruit some objects for the printing. So we have a print dialog, print document. So at least you should have a print document ready for it. So I drag in a print document. It is not displayable. Okay, it's fine. So we have print document ready. So I'm gonna call it MLP print DOC. Okay, so it's a document to be printed out on the printer. So it has a print page event. So if you subscribe a print page event, my MLP, draw MLP, right? As you can see, this is event handling function for print page, right? Print page is related to the printer. But printer is can be regarded as a graphics device too. So similarly, in the pass-in argument E there, you can find graphics. So right now, graphics is what? It's a printer, and also you have a more property for you to specify the size of the canvas. So you can see they have a page bounds. I think we also have margin bound, page bound, but usually you should spell the page bounds there. So we prepare a print, MLP print. It's a print document here. So how can we use it? So right now in our phone we have MLP print document object ready there. And then if we want to print that page, that document, then we have to invoke that draw function or the MLP there. So here, so print MLP. So usually you will pop out a print dialog here. So print dialog DLG. So dynamically created is okay. DLG if DLG show dialog. User really want to pen it, right? Okay. And DLG print print into file. Our excuse me, DLG print document. Excuse me. We need to specify the document is exactly the MLG print doc. So it's really want to print it. So we just show that it will be okay. Okay, it's interesting, right? So then let's see. Once we have this multi-layer processor ready, then reset it. So right now the content is right here. Is in, then print MLP. So document specify proceed. Okay, so how about this dialog of print document, right? So okay, it's a pity we cannot see the content, right? So it's just print. So you select a printer and then print it. Once you want to show it, so you can select the printer. So not this one. So probably let me how about the preview, print preview dialog. I think we have a print preview dialog too. You see, they have print dialog and also a print preview dialog. Print preview dialog. Actually, you can execute the print command. I mean, from print preview dialog, print preview dialog here. DLG new print preview dialog. DLG document equal MLP print docs. And DLG show dialog. Okay, forget about this print. So open the data set, reset. So right now we have graphics to represent for this MLP. So if the user want to print MLP, so this is a print preview dialog. So as you can see, print preview dialog will connect with that document, and that document has subscribe the print page event. So right now we can print. And print page event invoke this function. And this function take this device, this printer as the device. And then we give it the boundaries of that page. So right now it can be printed out in this way. But as you can see, the page, the bound is quite large, right? Because right now our printer is the resolution is 6 dots per inch. So as you can see, right now the circle is quite large, but the font size is still fixed. Font size is fixed. It's not enlarge or shrink it with respect to the bound size. So you need to do that in order to get a readable text coming out. All right. So that is the beauties of this draw function. Once you have a display device, the graphics can be always shown up in that device. So what's left? You should add the connecting link, right? So you can add a connecting link, and also specify and then show up the current weight. So somehow just take a look at the demo application. You should be able to do that if you are interested in drawing functions. So you can do that by yourself. Okay, is there any question about the drawing? As you can see right now, we fixed 5 pixels, right? So 5 pixels, that means 5 dots in that printer is quite small. So remember that your graphics element, the size should be scaled. I mean, with respect to the current canvas in order to get a consistent scale, right? So right now, font, and then this box size is not scaled with respect to the current bound. So that is reasonable, right? That can be realized. Well, the logic is in this way, so it will appear in this way. Okay, is there any question about what we have taught about today? So all the stuff are related to the graphics. And probably another important is that if your never mind, if we have since that if you keep changing the graphics contents, and then probably you will see screen flicking. In that case, I will show you how to eliminate the screen flicking. Okay, if you have this kind of problem. Okay. All right, so that will be all for today's lab. Is there any particular problem? Question about what we'll discuss today? So graphics. Okay, make sure you understand that. Okay, so what's actually your job? Should if you like to add the weight as a link, basically that is a line. And probably I will. Okay, so run a button. If we hit a button, we. Okay, pen, right? So we know the pen can be the width can be specified, but not just the width. We can also specify the end cap. So let me probably show you. We have a draw function here, right? This is draw graphics right here. We have pen, draw line here, P1, P2. I use my pen, so my pen is quite thicker, right? So again, you can specify some attribute for the pen. Of course, end caps. End cap can be specified by selecting an new. So end cap probably might call it wrong. If I call it wrong. So not the start cap. Another one is my pen start cap. So you can specify properly square or arrow anchor. So feel free to choose any one. So you can draw an arrow somehow. So you see, this is wrong, and the cap is wrong, and start cap is an arrow. Okay, just in case you like to draw an arrow, you can do that. So that is this line drawing. It is an attribute of pen object. So pen has a start cap, end cap, and also has width. If you use default pen, definitely just the width is just 1 pixel, and then there is no any cap, especially in the end or the stop point there. Okay, I think that will be the frequently used drawing function. So that will be enough for you to draw your neural network if you are interested in graphics a bit. But again, graphics is not required. It's not required, right? But I still hopefully you can learn a little bit about the graphics. On WinPhone. Eventually, you might find that will be very helpful if you later on if you have any particular problem in your final project. So probably you need to show some graphics display for your solution somehow. If you are dealing with certain kind of automation problem in your final project, you like to decode it, not just decode it, but you do want to display it. So the first choice should be the chart, right? If your final solution can be displayed on a chart, fine. You can just use the Microsoft chart. Either way to display the gain chart or a line chart or a bar chart there. But if it is purely related to, for example, if you like to draw the TSP route, right? So you don't need to draw it by yourself, but probably you would like to draw something particular which is not provided or supported by the chart. You should do it by yourself. So in that case, you can draw it using this draw function to do that. All right, that will be all for today. Okay, that will be all. So if you don't have any problems, we will end it up here. If you have problems, you can come up to check with me. Okay.